All right, if we want to describe a wave's motion, we can do that using frequency, the number of cycles that happen in 1 second. So, cycles per second, as those waves pass by, we had 1, 2, 3, 4, 5 cycles, 5 waves, 5 cycles passed in just 1 second. So the frequency is 5 hertz. Now the new wave at the bottom, 1, 2, 3. 1, 2, 3 cycles passed in just 1 second, so it has a frequency of 3 hertz. Wavelength, comparing the length of one cycle of a wave. So there's just one cycle, and you physically measure it. We're going to pretend that's meters and say that's a wavelength. Notice the symbol there, lambda, wavelength of 1.7 meters. Whereas this one has a longer wavelength. We measure it, again, pretending that's meters. We got a wavelength of 3 meters. Amplitude. Amplitude is the height of the wave from the equilibrium position. So, equilibrium position, that at rest, if that is a water wave and the wave were to stop, it would all come to rest, that would be the height of the water at rest. So that's the equilibrium position. So that equilibrium position, we're measuring from that point. Physically measure it, that has an amplitude of 1.2 centimeters. Down here, amplitude, 0.7 centimeters. All right, velocity or speed of a wave. It's the speed of the linear transfer of energy, how quickly the energy moves from one place to another. Velocity of a wave is the frequency times the wavelength. So we need to take 1, 2, 3, 4, 5 waves in 1 second, our frequency of 5 hertz, multiplied by the length of that wave, 1.7 meters, to get the velocity of the wave, 8.5 meters per second. All right, our other wave, 3 waves in 1 second, so a frequency of 3 hertz. The length of each wave, 3 meters per second. 3 times 3, a velocity of 9 meters per second for the wave. Now let's do some practice on graphing waves. Here we have a graph of a wave. What is the wavelength? Analyze, look at it carefully. What is the wavelength? Okay, there's one wave, one cycle of the wave. How long is that one cycle? 7 meters. Okay? Now, let's talk about amplitude. The height of the wave. Analyze it. 7 centimeters. That's our amplitude. If the frequency is 5 hertz, what is the speed? So if we're given the frequency is 5 hertz, because we can't analyze, we can't get that from this graph. But if the frequency is 5 hertz, what's the speed? So using your formula up there in the corner, frequency times the wavelength. The frequency of 5, the wavelength of 7, multiply those together, a speed of 35 meters per second. New graph. What is the wavelength? Identify one cycle of the wave. And how long is it? 9 meters. That's the wavelength. Next question. What is the amplitude? Remember, height from equilibrium position to the crest. 5 centimeters. If the frequency is 4 hertz, what is the speed? Notice the formula up in the corner. Frequency of 4 hertz, wavelength of 9, multiplied 36 meters per second is the speed of the wave. New wave, new graph. What is the wavelength? Marking out one cycle, the length of that one cycle is 7 meters. That's the wavelength. What is the amplitude? Height from equilibrium position to the crest or down to the trough, it'll be the same. 3 centimeters. If the frequency is 4 hertz, what is the speed using your formula? Speed of a wave is the frequency times the wavelength. 4 times 7 The frequency is 4 hertz. The wavelength is 7 meters. 4 times 7 is 28 meters per second. All right, now we have 3 graphs. We're going to do a little comparison contrast of these 3 graphs. First, what is the same between these graphs? What do they have in common? They all have the same wavelength of 7. What is different between these graphs? They all have different amplitudes. This one has the smallest amplitude, this one has a medium amplitude, and that one has the greatest amplitude right there. Compare and contrast. Assuming both waves have the same speed, let's do a compare and contrast. What do you see there? Mark using the little purple dashed lines kind of help to visualize there. They all have the same wavelength. Both of those 2 waves, 1 and 2, have the same wavelength. But what does that show us, those horizontal ones? It shows they have different amplitude. Okay, compare and contrast. Different wavelengths, same amplitude. Compare and contrast. Again, different wavelengths, same amplitude. Good job.